sometimes speech phoneme consists of a speech phoneme duration is 100 milliseconds, sometimes speech phoneme duration is 80 milliseconds, 120 milliseconds. But if we go with the STFT, that is applicable to the 20 millisecond, 30 millisecond, and 40 millisecond duration. To overcome the limitation of the time, here we can apply this model only on a single phoneme duration length. That is a 100. That can be a 100 millisecond duration. So what is our aim first? This is a speech signal that should be labeled at the segment. That should be segmented at the phoneme level. Means phoneme if I speak any word that consists of multiple phonemes. So this component will be separated as a multiple phoneme. Then here this capital Xn is represented to the speech phoneme. This is the continuous speech Xn, and Xn is a single phoneme from that speech that is extracted by using phoneme level segmentation. So this capital Xn is what? Capital Xn is multi-component signal that we are showing here. Multi-component, multi-tone AFM signal model. We are representing the speech by the capital Xn. So now Fourier measure will be applied here, and it will be split into single component like x1n, x2n, x3n, and xkn. So now after this Fourier measure expansion, we will get this part, small xn. Okay. So here we are getting the different mono component. Now what is our next aim? Our aim is to separate this part AM and separate this part FM. Then we do the analysis on this part. Then we do the analysis of this part. So we are going step by step. First we have a complete speech signal that we segmented into short frame. Short frame is at the phoneme level. Then phoneme level signal will give to the Fourier Bessel expansion that will separate the component into the single component which is small xk, and the Fourier Bessel expansion will be given to the discrete energy separation algorithm. This BESEL is what? Discrete energy separation algorithm, which will help us to extract the amplitude envelope and the standard frequency. So what is the amplitude envelope? This part is the amplitude envelope. This part is the amplitude envelope. With the help of data, we can get this part, and we can get this one will be applied to this, and we will get A1n and omega 1n. Similarly for xkn, we will get akn and omega kn. After that, this from here, what is this? A1n. What are the present in the A1n? In the A1n, in the AN, this is the amplitude envelope. What are the present in the amplitude envelope? In amplitude envelope, it consists of amplitude A, mu A, which is the modulation index of AM part, omega A, which is the modulating frequency of the AM, theta A, which is the modulating phase of the AM. So that can be extracted with the AM parameter A1, omega A1, mu A1, and theta A. Similarly, in the FM parameter consists of scanning frequency omega C, mu F, which is the modulation index of FM, omega F, which is the modulating frequency of FM, and theta F, which is the modulating phase of the FM. So that can be extracted with the FM parameter. So now we'll see this briefly one by one block, like how Fourier Bessel expansion work, how BESEL can work, then how do we extract all these parameters. Fine. So here we see the Fourier Bessel expansion. You can see the Fourier Bessel expansion where this is the complete speech phoneme signal. This is a speech phoneme signal, and Fourier Bessel is applied here, and you can see the x-axis is the Fourier Bessel order and y-axis is the Fourier Bessel coefficients. So in this signal, you can see the multiple spectrum. So this can be one component, this is another component, and this is another component. So this is a voice signal and format one. This component, first one where zero coefficient are present. Before that, we have some coefficients which indicate to the format one. This is related to the format 2, this is related to the format 3. So by using this equation, we can get this representation Fourier Bessel coefficient, and to get the individual component, we will select only these number of orders. Like here we have around 80 to 100 Fourier Bessel order that will be fitted in this equation.